Hello everyone, my name is Benjie Wang, and today I'd like to present a work, Tractable Uncertainty for Structure Learning. So we're interested in the domain of causal structure learning, where the goal is to learn a directed graph representing causal relations between variables. So to give you an example, it's long been known that Alzheimer's disease is associated with diabetes, but what we really want to know is whether there's a causal link, as then we might be able to use certain diabetes drugs to treat Alzheimer's. But it's often the case that we can't, or it's not reliable to infer a graph with certainty. So an important question is how to represent this uncertainty with distributions over the graph given the data. And you'll see two immediate challenges here. First, I've only shown you 3 graphs. In reality, there are over 29,000 for 5 variables. And this grows super exponentially, so we need scalable methods. And second, we need to be able to tractably reason to extract useful information. For example, for linear causal models, we can derive these expressions for the causal effect, and this depends qualitatively on the graph, so it's very unclear how we can reason about causal effects over the whole distribution of graphs. So it turns out that this problem is essentially equivalent to expressing distributions over orderings or permutations of a set. And what we propose in this work is a novel tractable probabilistic circuit called an order SPN for representing such distributions. To give you a brief idea of the theory, a sum node is a mixture of its child distributions, where each child corresponds to some partition of the set, and then a product node expresses an independence assumption, where here, knowing how 1 and 2 are ordered doesn't tell us anything about how 3 and 4 are ordered. Okay, so perhaps unsurprisingly for many of you, it turns out that order SPNs support a number of tractable inference queries that previously proposed models do not, but perhaps equally important is to go back to the original application domain of causal inference and think about the interpretation. Thank you very much for listening, and please come to our poster to find out more.